Good day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamentals on YouTube. Please, before we go into today's exercise, do not forget to like, share, subscribe, and click on notification button to have more of my video. Thank you. Today we are taking a topic in physics, and that topic is under modern physics. And the topic we are taking, the part one, is called the impact parameter, and then the part two is about the calculation of the the nuclear radius of a nuclei according to Rutherford equation. So the first topic we are taking here is impact parameter and Rutherford's nuclear radius R. What will you mean by that? Let's start with the impact parameter. The impact parameter is talking about when the stream of alpha particle. Alpha particle is more or less like the nucleus of helium. So the alpha particle is represented with this symbol, alpha particle. When this particle is directed under the influence of the voltage, the potential difference, let's say the potential difference of 10 electron volts, 10 electron volts. This alpha particle is targeted against the nucleus of a gold foil. This is a gold foil. Gold is AU. After this particle, the stream of this particle hits this particular gold foil. Because of this obstacle, the particle are scattered at a particular angle. Let's say the angle is 46 degrees centigrade. So the question says we should find the impact parameters. Impact parameters is this is the closest distance of approach of this alpha particle to the radius of the gold foil, the nucleus of the gold foil. So the distance B is called the impact parameter. So we want to find this closest distance to the radius of the gold foil. Now, this particular alpha particle is being projected with a kinetic energy. So this kinetic energy is given as the atomic number of this helium times the electrical charge, square of electrical charge, all over 4 pi E naught. Then this impact parameter radius, then times the tan of the half of the angle given, the angle theta given, tan half of it. So if you want to get this impact parameter B, we can make it the subject of the formula, and it's given as this. When we take this B here, this kinetic energy will come down there. So we have the atomic number of this gold foil times the electrical charge squared all over 4 pi E naught, then kinetic energy, then tan theta all over 2. Now this particular one, please take note of this. 1 over 4 pi E naught is a constant. 1 over 4 pi E naught is a constant, and is given as 9 times 10 raised to power 9 in magnitude. So this formula can be rewritten as Z is equal to the atomic number of the gold foil times the square of the electrical charge, then times this particular 9 times 10 raised to power 9. I replace it with 1 over 4 pi E naught. That's 9 times 10 raised to power 9. Then divided by the kinetic energy, then tan theta all over 2. Now the kinetic energy Ke is given as 10 electron volts. 10 electron volts. But 1 electron volt is given as 1.6 times 10 raised to power minus 9 coulomb of charge. So this kinetic energy can now be written as 10 times 1.6 times 10 raised to power minus 9. So I'm going to substitute each of the parameters that I've obtained into this equation. Now, the atomic number of the helium stream of helium is this 2. So I'll put it there. So I'm going to have 2 times the electrical charge is given as this particular value true. That's 2 times 1.6 times 10 raised per minus 19. Sorry, it's 1.6 times 10 raised per minus 19 times 10 raised per minus 19. Then I'm going to square it, squared. Then times, because I'm using this one now, 9 times 10 raised to power 9 all over. The kinetic energy that I've gotten here is 10 times this value that I have here, 10 times 1.6 times 10 raised by minus 19. That's 10 times 1.6 times 10 raised by minus 19. Tan half of this angle. The angle given, theta, in this question, I think it's 46 degree, this angle. So we are going to find the half of 46 degree, and the half of 40, that's theta over 2, is 46 divided by 2, which is 23 degree. So I'm going to put 23 degree in this theta divided by 2. I put 23 degree there. So if you look at this parameter here, they are the same thing. So this one, we cancel this one, so we are going to have one of this one up. So using our calculator, we are going to have something that is given as a 4.59, no sorry, 2.68 times 10 raised by minus 8. That's a 2.68 times 10 raised by minus 8 meter. So that means the impact parameter, the closest distance of this stream of alpha particle to the goal forward, is B, which is this impact parameter. I want to say thank you for this first session of this problem that we are solving. In my next video, we are going to calculate the Rutherford's nuclear radius R. So please, before we go, do not forget to like, share, subscribe, and click on the notification button to have more of my video. My next video now, please, you can click on the next video to look at the next exercise on the Rutherford's nuclear radius. Thank you for watching. Bye.